This is what it looks like when we have superimposition. So this is what triple turret capability looks like in certain situations, where the sub spindle is working on the back side of the lower turret and the lower turret is working on the main spindle simultaneously, as the upper turret is independently machining on the main spindle. Now you're going to see them break into individual programs. So the sub spindle is going to be working with the lower turret. This is actually going to be a dynamic polar milling program. So we don't have a y-axis on the lower turret, but we're kind of milling y-axis features and off-center. The way that that works is the C-axis is actually acting as a y-axis. So the X is moving in and out, and the C is following it, and it allows us to cut y-axis features. So the way that that would be programmed is you program it just like normal XYZ code. And then there's a G12.1 that we put in there, and the machine takes care of all the calculations to be able to make that possible. You're going to see the upper turret here working on the main spindle. That's going to be machining the OD flats. There are lots of different ways to tackle this. We could have done a polygon milling program. We could have also done a polar milling program from the face. Any one of these works. I just chose to use an X-axis holder here. So on the bottom turret on the sub spindle now, you're going to see a chamfer program. So again, we do not have a y-axis. So normally you would think that you need a y-axis to be able to mill those flats, but we're actually going to be using the G12.1 again, and the machine's just going to be able to mill all these features using the C-axis and the X-axis. On the upper turret now on the main spindle, even though that we have 6,000 RPM capability with our live tools, this is actually a speeder head. It's a 5-to-1 speeder head, so I think around here we're doing a 25,000 RPM spindle speed. It allows us to drill much faster with a 60,000th drill. So on the lower turret on the sub spindle now, you're going to see an engraving cycle. In this engraving, if you look at the part, we do not have a y-axis again, but it looks like you need a y-axis to be able to do this engraving. The way that that's possible is that G12.1 again. For some reason that we needed a y-axis, if there was an offset feature on the OD of the part, we can use the upper turret because each turret is capable of working on each spindle independently or simultaneously. So on the upper turret now, we're going to be chamfering the ID of those holes. Now we're going to be doing a radial polar milling cycle. It kind of works the same as doing a face polar milling cycle, except it's on the OD of a part. So it's allowing me to chamfer all these flats without using the y-axis. It's just a little bit faster than moving up and down with the y-axis. And I'm only climb milling here as opposed to climb milling and conventional milling as if I was using the y-axis. So here we're boring the ID just to finish it up and remove the burrs. And now we're going to start our part ejection cycle. So this is an included option on every Miano BNE. It's going to be a parts catcher arm. Parts catcher arm will come up to the sub spindle. It will grab the part and then drop down onto a parts conveyor and eject outside of the machine. So here during our cutoff cycle, you're going to see a quick pullback. It's only about 100 thousandths. It only takes a second or two. And the advantage of this is actually doing a torque sense. So it's checking to see if our cutoff broke. If our cutoff broke, it wouldn't have cut all the way through the material, and it would know that it's still attached to the main spindle when it tries to pull, and it would alarm out immediately. This prevents lots of tools breaking after the cutoff during our next part cycle. This is going to be a better example of superimposition, so it really shows off the 3 tools in the cut at once. Here we're going to be pinch turning on the main spindle, which is very popular, and we're going to be drilling on the back side of the turret at the same time. This is a huge time saver in the industry and really what sets us apart to our competitors. So here we're going to be grooving on the main spindle. Right now the sub is just following, it's not doing anything. It's just getting ready to finish this face on the back side. So we don't gain full triple turret capability, but a lot of times we can save quite a bit of time by finishing on the backside at the same time. So here again, you're going to see us boring with the upper turret, finish turning on the main spindle with the lower turret, and finish boring on the ID with the backside of the lower turret on the sub spindle. So here, this is really going to set us apart in the industry, is we're actually going to be turning on the upper turret or grooving, and then we're going to be threading on the main spindle with that turret. On the backside, we're going to be threading simultaneously. So the sub spindle is actually following the turret and keeping up with the threading cycle on the backside as it's independently threading on the main spindle. So we're not just limited to superimposition with the lower turret, this is going to be showing superimposition with the upper turret at the same time. So now the upper turret is going to be drilling on the main spindle, it's going to be turning on the sub spindle, and then the lower turret is going to be doing its own thing as it's turning on the main spindle. So here we're going to display some shell mills. These are going to be geared down holders. So we have 6,000 RPM tooling on both the upper turret and the lower turret, but these geared down holders allow us to spin at 6,000. The output is actually going to be at 3,000 RPM, and then as it cuts, we gain double the torque. This is going to show a better example of the superimposition using the upper turret on the main spindle and the sub spindle, with the lower turret working individually on the main spindle. So here we're going to see our mirror imaging. What this is doing is we're engraving on the upper turret here, and the lower turret is actually just following the main turret. What this allows us to do is it's actually engraving one image right side up on the upper turret, and it's going to be upside down on the lower turret. So we're actually going to be picking up on this part on the flats. So the sub spindle is actually going to sync at an RPM, come over to the main spindle, grab the part, and then we're going to pull out the part for the next part length so we're ready to go, so we don't have to use a bump stop, and then it's going to cut off and finish the transfer.